So here we have both a production, kind of a, let's talk about verbosity. Verbosity is your friend and it's your enemy. Verbosity is your friend when you're reading a script that somebody else wrote or a script that you wrote a year ago. Okay, so we support verbosity. Get process, my process name, LSASS. Okay, we fully support that. Verbosity is your enemy when you're a power user and you want to get some stuff done. So look, you just have to provide enough of the switch to tell it for us to disambiguate, and we support aliases and positional parameters. So we're both verbose and pithy. So too, now we'll say, hey, let's get rich targeting capabilities. I want to see everything that begins with an A through a C, or T through Z, and doesn't have a C through a G in it. Okay, pretty wacky stuff. But very rich targeting capabilities. So because we're an object-based system, we can do wildcarding on a wild set of objects,
now,
not just file systems.
What is this language?
So this is the MSH language, okay, and it's very regular. It's not like the other languages. It's new. You are going to have to learn it. But we're trying to emulate the VMS experience, right? In VMS, you use VMS DCL, and you say, what the heck is this thing? And then you say, this is not like anything else I've used. Then all of a sudden, after about 20 minutes, you say, oh, I get it. And there's a single parser, so everything has exactly the same syntax. They've been hardcore about naming. In the later years, they got a little bit wobbly on that. But at the beginning, they got pretty hardcore on the naming. So once you learned a set of names and the syntax, then after about an hour, you could do anything. There's a great joke in the Unix, in the VMS community, where you say, hey, if somebody goes up to a VMS admin and says, someone put a fish finder on the VAX last night, do you know how to manage it? The answer is, of course. Show/fish finder, get fish finder /before/notify, etc. They just will guess because there's such a strong pattern, and 70% of the time the guesses will be right, and where they're not right, they'll know how to get the information. That's the world we want to reproduce. So it's a very consistent environment. You're going to have to learn it. But then once you learn it, you'll be able to apply it to everything. Okay? So back to this model of, hey, you know, I did this funky thing, and now I want to stop it. You can just say, what if you're not sure. And here it tells you what it would have done. Then you can go and say, well, that's not quite what I want to do. Let's do confirm. You want to do that one. Yes, yes to all, no, no to all. We'll say no, say no, say, hey, what's going on here? Suspend, take a look around, see the system, say exit, get back to the question, and now we'll just say no to all. So very rich environment. So too, we provide tight controls over error processing. One of the big differences between us and every other system, right, is that other systems view errors as like this aberration, right? Well, things are going to work fine, but then sometimes something might go wrong, and so we'll have some handling for that. We don't think of that at all. We think of errors as being first-class citizens. Things are going to go wrong. Things are going to go wrong all the time. You probably perform an operation on 1,000 nodes, it's never going to work on 1,000 nodes, right? And the worst is it's going to work on like 950 and then fail on 50. So the industry standard solution to this is just to keep trying, or like hunt for the intern. Hey, you bucko, come here. Go through this log, find those 50 things, and do something right with it. We say is, that's going to happen all the time, all the time. So we say is, hey, when you operate on a stream of things, we split that stream into the things that worked and the things that didn't work. And the things that didn't work is a collection. It's a collection of objects, and you can perform remedial actions on that, etc. When it doesn't work, boy, we spend time, resources, CPU, memory to get exactly what went wrong and why it went wrong. Again, because I'm focused in on your resources and your time and not the machine's time. So we really treat errors as first-class citizens. So the next thing is the ability to take a look at the system. So here we'll do get drive. Now notice you'll see some of your traditional drives, right? The C drive, the D drive. But notice there are some new drives. There's the alias drive. There's the cert drive. Down below you'll see the HKLM drive, music, etc. So these are all drives. So what I'll do is, just as I can do a dir, right? What I can do is I can now say cd to HKLM software, and now watch, I'll hit a tab. You have command completion in the registry.
That's cool.
When I do a dir, here are all the registry things. I do a dir of webm, I get the registry keys. Can do the same thing in AD, dir AD. You can navigate around Active Directory. You can go into your cert store. Take a look at all the certs in the system. So too for aliases and variables. I can say $G equals get all the processes, and then do a dir of variable. So the variables, your local variables, are surfaced as a drive as well. So you can grep your variables. Yeah, right. Wait, let me say that again. Your system state, your aliases, your functions. Look, dir of the functions, dir of the aliases. Right, dir of the aliases. There are your aliases. You can say, well, tell me all the ones that begin with a C. There they are. They all begin with a C. Oh, what about my functions? Function. Oh, cut that out.
No! If you crash, you're on air.
We always use singular terms, because plurals, the English language is ambiguous, so we always use singular functions.
Right.
So here are all your functions. You can say, well, show me all the functions that begin with an N. And you find those. So basically, your entire system state is exposed as a set of drives. Yeah. Here's. So what about this object stuff? Object pipelines. So here are all the processes, right? All the processes. But now what I want to do is I want to say, find me all the ones where the handle count is greater than 400, and sort it by handle count. Okay? So you just think about what you want to do, you type it, and you get it. Okay? Now, I mentioned that we're not walking away from the GUI, right? A lot of administration is about getting information, analyzing that information, and acting upon it. Well, it turns out that Microsoft has one of the best data analysis tools in its portfolio. And it's a crime that it's been difficult to get your system management information into that tool for analysis. So let's fix that.
I knew you were going to do that.
And so here are all the attributes of all your processes in Excel. And if I was an Excel wizard, at this point, I'd start doing pivot tables and showing you how the barking dog can help you find out what's wrong with your system.
Right.
So we fully support both a command line environment, a graphical environment. The object-based pipeline provides you unprecedented power. Here, let me show you another one. So you say, hey, let's get a list of these processes. Now, what's the benefit what's the benefit of live objects? Oh, here's what we'll do. So we'll start a couple processes. We'll take a snapshot of the processes, and then we'll go ahead and kill. I'm going to kill Notepad. Kill Calc. I'm going to kill Notepad. And now what I can say is, I had that snapshot of processes. I'll say, give me the processes where the things have exited. Okay? And so there's obviously a background process that exited in between the snapshot and now as well. But notice I didn't have to get a list and then get another list and do some complicated functions. The fact that I have the object, and the object has state, and that state is constantly reflected and it reflects the system state, means that it dramatically simplifies the admin experience.
Right. That's wild.
Yeah. Here, what I can do, and
So
because I have an object,
Monad is all this, is just this command line, right?
it's a command line and it's a set of libraries.
You don't have any GUI or anything.
Correct.
It's just this with a set of libraries.
Yep.
So what are the 5 things, when I first get Monad,
Yep.
I'll probably get it soon.
Yeah.
What are the 5 concepts that I need to know? What
concepts.
Starter concepts. Get me started. What are, the 5 things that will get me started and get me
into
Monad?
Yeah. One is strong naming. So we got very strong naming. You're going to walk through our guide. Pay attention to the verbs. What we try and do is manage 80% of the system with under 50 verbs. So you're going to learn those verbs, right? Then you're going to learn a noun, and you're going to develop this intuition. Geez, there's only 50 verbs. Which of those makes sense of this noun? You're going to make a set of guesses, and you're going to be right. Okay? So one is the naming. Second is the help. Whenever you're in doubt, get process dash question mark, and you get the help. Okay?
Okay.
So third is we're an object-based system. So whenever you see something, realize that behind it is an object, and you have infinite control over that thing. This help is just a reflection of a help object. The fact of the matter is each one of these things, the name, the synopsis, etc., that's all properties of an object. And so you can perform any of the object utilities on it.
Right.
Okay? So you could have said, get help on everything, format, table, name, synopsis. I think I spelled that right. Okay, so here are the names and here are the synopses. So you have, so everything is an object, and you have infinite control over those objects. To exploit that infinite control, you're going to want to spend some time with our object utilities, the where, the for each, pick, group. Here, let's do group. Get processes. Let's group them by company. Okay, so this is telling you you have 31 processes from Microsoft, and here are the processes. Okay, you can say things like get processes. Let's measure the handle count and group it by company. Object. And so what this is telling you is it's telling NVIDIA has 82 handle counts, and there's only one. Okay, so you sum up all the handle counts based upon the company. So again, this is the thing I'm saying about, boy, you should not assume a fixed world. You should assume a world where any question you want, you should be able to answer it. So the utilities have the flavor of both the Unix type utilities, head, tail, pick, sum, etc., but then also SQL type utilities. So you can do things pretty darn cool. Yeah, so basically we have SQL type utilities as well. So what I can do is get processes for MSH and pick the process name and expand the modules. Now what this does is it lists all the DLLs in use by the MSH command. Now what I can do, so basically it produced a table for that. Now what I'll do is I'll produce a table for all the processes, and I'll format as a table the process name and the module name. So you see, it's showing you all the processes and all the modules, because then what I can do is I can say, now let's group this by the module name. Let's sort it by count. Let's do a tail and format it as a table based upon the count and the name. This will take a while. It's a pretty complex expression we've done there. And so what this is telling you is OLE 32 is the most used DLL in use right now. There are 37 processes that are using it. Next comes, oh, you know what? I got that the wrong way. So ComCuddle is the most used one with 74 processes using it. Above that, NTDLL with 44, etc. So this was taken by getting all the processes, expanding them to produce a table of process and DLL, then group all the DLLs, sort them by count, grab the last 10 and format it as a table. I mean, you've never been able to do stuff like that. So you're going to be able to ask questions about your system that you've never done before. So just explore, just have some fun, explore, figure out what your system is, because then when things start to go wacky, you need to understand how your system really works, so then you explore and you do it.
That's
then
awesome.
you can see what the differences are.
This is really cool.